Hi everyone, welcome back to the Comptia Network Plus course. Loopback Adaptor plug. A loopback test is a diagnostic procedure in which a signal is transmitted and returned to the sending device after passing through all or a portion of a network or circuit. The returned signal is compared with the transmitted signal to evaluate the integrity of the equipment or transmission path. A computer needs a loopback plug to be inserted into a port in order to perform a loopback test. Loopback plugs are made for both Ethernet and fiber applications. Figure 1816 shows an Ethernet loopback plug and figure 1817 shows a plug for fiber applications. So here you go, this is an Ethernet loopback plug and this is for fiber optic cable. Wire map testers. A wire map tester is a device that transmits signals through each wire in a copper twisted pair cable to determine if it's connected to the correct pin at the other end. Wire mapping is the most basic test for twisted pair cables because the 8 separate wire connections involved in each cable run are a common source of installation errors. Wire map testers detect transposed wires, opens, broken or unconnected wires, and short wires or pins improperly connected to each other. All of these problems can render a cable run All of these problems can render a cable run completely inoperable. Wire map testing is nearly always included in multifunction cable testers, but sometimes it's just not worth spending serious cash on a comprehensive device. Dedicated wire map testers that run about $200 or $300 are relatively inexpensive options that enable you to test your installation for the most common faults that occur during installations and afterward. If you say you're installing voice grade cable, a simple wire mapping test is probably all that's needed. A wire map tester essentially consists of a remote unit that you attach to the far end of a connection and a battery operated handheld main unit that displays the results. Typically, the tester displays various codes that indicate the specific type of faults that it finds. You can also purchase a tester with multiple remote units that are numbered so that one person can test several connections without constantly traveling back and forth from one end of the connections to the other to move the remote unit. Continuity testers. A continuity tester or line tester is an even simpler and less expensive device than a wire map tester. It's designed to check a copper cable connection for basic installation problems like opens, shorts, and crossed pairs. It will set you back only a few dollars, but such a device usually can't detect the more complicated, twisted pair wiring faults. It's still a nice option for basic cable testing, especially for coaxial cables that have only 2 conductors, and so don't easily confuse whoever is installing them. Like a wire map tester, a continuity tester consists of 2 separate units that you connect to each end of the cable you want to test. Most of the time, the 2 units can snap together for storage and easily testing of patch cables. But remember, a continuity tester simply tests continuity equivalent to data at 1 bit per minute or slower and can tell you whether or not the cable will reliably pass Ethernet data at network speeds. For that, you need a real cable tester that can test cables up to gigabit speeds or higher. protocol analyzer. A protocol analyzer is often confused with a packet sniffer because some products really are both. Remember, a packet sniffer looks at all traffic on a network segment. On the other hand, a protocol analyzer analyzes protocols. These tools come in both software and hardware versions, but compared to products I listed earlier in this chapter, a network protocol analyzer is likely to give you more information and help than a sniffer will. This is because a bona fide protocol analyzer can actually help you troubleshoot problems, whereas most sniffers just provide information for you to have a ball deciphering. A network protocol analyzer can perform the following functions: help troubleshoot hard to solve problems, help you detect and identify malicious software malware, help gather information such as baseline traffic patterns and network utilization metrics, help you identify unused protocols so that you can remove them from the network, provide a traffic generator for penetration testing, possibly even work with an IDS. And last, perhaps most important for you, they can help you learn about networking in general. This means if you want to find out why a network device is functioning in a certain way, you can use a protocol analyzer to sniff the traffic and expose the data and protocols that pass along the wire. Certifiers. Certification testers or certifiers are used to determine whether your network meets specific International Organization for Standardization (ISO) or Telecommunications Industry Association (TIA) standards Cat 5e, Cat 6 or Cat 7. They are the only option for you in this case. Also, if your network is wired with both copper and fiber, you really must use a certification tester. Basically, a certifier is a combination cable tester and network analyzer, only better because it comes with more options. This is wonderful because it makes your job easier and makes you seem smarter to everyone around you. You're only as good as your tools, right? A good certifier will test the performance and response times of network resources like web, file, email, and even DNS and dynamic host configuration protocol (DHCP) servers. And at the same time, it will certify your full category 6 cable installation. After it finds all this, you can provide your boss with a detailed network test report complete with dazzling colourful graphics to make it simple to explain and understand. You're instantly a genius of the day. To get these smarts, all you need is a lot of money. These products are not for the small office, home office, SOHO market because they cost literally thousands of dollars, starting at around 5,000. Time domain reflector. A time domain reflector (TDR) is a tool that finds and describes fault in metallic cables like twisted wire pairs and coaxial cables. The equivalent device for optical fiber is an optical time domain reflector (OTDR), which I'll talk about in a minute. A TDR works in the same basic way that radar does. It transmits at a short rise time pulse along the conductor, and if it turns out to be of a uniform impedance or properly terminated, the entire transmitted pulse is absorbed in the far end termination. No signal is reflected back to the TDR. Any impedance interruptions will cause some of the signal to be sent back toward the source, letting you know all is not well. So basically, any increases in the impedance create a reflection that reinforces the original pulse and decreases the impedance. thereby creating a reflection that opposes the original pulse. The resulting reflected pulse that's measured at the output input to the TDR is displayed or plotted in measures of time, and because the speed of the signal propagation is pretty consistent for a given type of transmission medium. The reading can also tell you about the cable length because of this sensitivity to any variation in impedance. You can use a TDR to verify these things: speed and condition of the cable, how long it takes to send a signal down a cable, how long it takes to come back, cable impedance characteristics, splice and connector locations and their associated loss amounts, estimated cable lengths. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and give me a thumbs up. Thank you.